time today. Let me pull up my slides and start sharing my screen. As a reminder, this is class number 5, so you finished already half the course. Last class we talked about Java strings, and we just started talking about them, and we're going to continue talking about them today. But I wanted to focus on a review question, and it's talking about a thing that we said you can do with strings. So as a reminder, strings are just basically the data type that's associated with text. So first we talked about chars, which is short for like a single character. Strings are just a bunch of chars, essentially. It's just a lot of characters combined together. One thing that we said you could do with strings is this index of method, we called it. So methods are just kind of like tools. They do things. Index of is a method that works with strings. So this index of, we're saying index of parentheses C, comma 2. So I guess first of all, David says index of the last string before the provided index. So be careful. So I think, Devin, you're almost correct. You're confusing a little bit with a different method, though, a method that you have to use on the homework. That was a slightly different one than this. So there's index of and there's last index of. So this one is not last index of, it's index of, no last. So we're not finding the last time it occurs. We're actually finding the first time it occurs. But that 2 does something special. So first of all, does anyone want to tell me know or guess what is it going to return if we use the string cupcake? So we basically say cupcake dot index of C, comma 2. So David says 3. Does anyone else want to give an answer? Maybe let's get three people. Okay, Andrew says 3. Anyone else want to agree or disagree with 3? All right. So I'll give out the answer. The answer is 3. Yeah, thank you, Devin. So C, clearly the C is kind of like what we're looking for, right? So index of C, we're looking for C's in our string, right? So I added some spaces here, but it's actually just on the cupcake. I just spaced it out for us to look at, but it's correct. If there are actually spaces in between the letters, then it would make a difference. But anyways, index of C. So if we just ignore the 2 for a second, index of C is basically looking up C and finding the index. And we talked about last week that indices are just like the positions of things. So index of C is just says, what is the position of C in our string? And the only special thing about indices is that they start at 0. So this first character is at index 0, not index 1, index 0. However, if we just had index of C, it would return 0 because it finds a C immediately and it's done. It stops. Right? However, because we add this 2 is an optional argument. You don't need to have it. But since we have it, it's saying, hey, I don't want you to start looking at the beginning. I want you to start looking kind of halfway in the middle, right? In this case, we're starting to search for C's, not at the beginning, but at index 2. So if we look at the string 0, 1, 2, we're actually looking for C's in this part of the string. Because of that, we don't see the first one. We don't return 0. We go, okay, P is not a C, but then the C is what we're looking for. So then it returns the index of this C, which happens to be 3. Right? Because it's 0, 1, 2, 3. Right? The homework for this week was pretty similar. Kind of used this kind of concept indexing. And I was really happy to see a lot of homework submissions, and they all looked really good. I think I left a comment for everyone that submitted at least a couple of minutes before class. I checked. Really happy about that. But just going over the solution, just in case you had some questions or wasn't sure how to do it. This is what I'm showing is pretty much what everyone did to some extent. Yeah, no problem, Devin. Late is better than never. So the homework began with, I gave you this input. So I said, you're working with this string, and you just had to create a variable that holds the string hello all audiences, right? The first part was finding the last index of A, starting looking at index 13. And so the thing that you have to know is using this last index of function or method, and how do you use it? And so the first thing is what you're looking for. The second thing is where do you start searching from the position? So here we're looking at our string x. This is our input. We're finding the last index of the character A, starting looking at index 13. So index 13 is somewhere around here. We're looking for the last occurrence of A from there. And since we're going the last index of, we're going to the left. Right? So going boom, 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 we find this A, and it happens to be index 10. Right? I'm doing some printing later on. Last index happens to be 10. I also wanted you to find the length of the string, and I showed you how to do that last week. It's just another method. Here, it's just x.length. Notice the difference is index of, you need to some sort of inputs, right? You need to know what you're looking for. You need to know where you're starting from. Length, on the other hand, doesn't need anything, right? It doesn't need any inputs because it already knows what string you're talking about. You're talking about x right here. Length is very simple. It returns the length of the string. It doesn't need anything else. And so that's why you don't have anything in the parentheses. Anyways, you call x.length, and then you need to store it into a variable. The other note here is like the type of the variable that you're storing it in. So last index of returns an index, and indices are just numbers. Specifically, they're just ints. So we store the index into an int variable. The length is also just an int. So we store it into this int variable. And we can print out the results, the last index and the length. Right? So 10 and 19. Then I wanted you to find the difference between the two and find the character at that index, right? So finding the difference is just doing the minus sign. This is one of the, like maybe the second class we talked about, you can subtract numbers like a calculator. And I store this into a variable. Yeah, I just do this to have multiple steps, so like each step is small. You could have combined these two lines or couple these lines together. But the difference happens to be 9 because 19 minus 10, no surprise. And then we find the character at that index. So I stored the index in this variable called diff. And so now the third and final method that we talked about was the char at method. It's kind of like index of, but reversed, right? Index of takes in a string and looks for that string and gives you the position. Char at, on the other hand, you takes in a position and gives you whatever's there. So yeah, so I wanted to know, it's a little bit tricky. So if you notice here, it says chart that index, and it looks like it's printing out nothing. But I think a couple of you guys realized what was going on. Yeah, and Devin, I think you figured it out. It is a space. And so it's like actually something I wanted to point out. In case you didn't realize already, spaces count as characters, right? So looking at this string here, hello all audiences, just wanted to make it clear. These spaces are actually characters in the string. They're just like any other character, right? So here we're finding the character at index 9 because that's what the difference turned out to be. And if we go in this string, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. the 9th character, or the character at index 9 happens to be the 10th character. The character at index 9 is a space. And so what it's actually doing is it's printing out a space. We can't actually see it, but if I added something maybe to the end and run it, you can see there's the space is right there. The character happens to be a space. Right. Any questions about the homework? I think from what I saw, mostly they all look good. The one thing I will say that's like the important part about this homework is one, using the different methods. Last index of, length, char at. These are things that you should try to practice with. The secondary thing that's important to take away from this homework is if you did it in a way like how I did, which I think some of you did it, when you're calling these methods, they return some sort of value. They give you something in return. And so you have to store them into a variable. Not only do you have to store it into a variable, but you have to know what type of variable you're going to store it into, right? So last index of and length, these return numbers. So you have to store them into an int variable. However, char at, based on the name, it returns a char. So you can't store this into an int variable. You have to store it into a char variable. Or at least it's not useful if you try to store it into an int. Yeah. The third minor thing is just spaces are characters too. Those were, I guess, the three main takeaways from this homework. With that, I do want to head into the slides for this week. We're going to be continuing to talk about strings, and we're getting into like a couple more methods, use very useful methods that work with strings, as well as some more advanced topics. We'll see how far we get. Let me switch back to the slides. As a reminder, if you can pull up Eclipse on your own computer, I'll be showing you code snippets, showing examples, but it's more useful and I think a little bit more fun if you run it on your computer as well. And you can play around with it and change the example to see what happens. So just start up Eclipse while I'm talking if you haven't already, because I know it takes a little bit of time to start up. The first thing I want to talk about today is about comparing strings with each other. And this is actually maybe a little bit more complicated than you might think initially. And so we've already talked about one way of comparing things. We talked about how to compare numbers with each other, like ins or doubles, and it's with the double equal signs. And so technically, what you see on the screen is valid Java code. This will compile, it will run, there's no errors. But there's kind of a bug in it. I'm going to explain why you should never use the double equals to compare strings with each other. So let's see this. Let me just copy this into chat. But also on my side, I'm going to make a new Java class. This is class 5. I'm going to select this option, finish, and I have my new Java file for today. I'm going to paste it in right here. So Alan says it will return 0. Close, it's not going to return 0. It looks like it's working. All right, so it prints out false. So it looks like it's working, right? And actually, if you play around with it, it actually looks like it does what you think it does. If I change S to instead be hello to match what T is, and we run it, it does say true, right? So at first, it seems like it works, right? And that's why this is so tricky, And this is why it will cause you a lot of pain. Because in a lot of cases, this equals comparing strings does what you want it to do, or at least looks like it does what you want it to do. However, it's not quite right. And so in a few edge cases, it will mess up and do something that you don't expect it to do. And so that's why it's so tricky and important to get down. I'm going to show you an example where it doesn't do what you want it to do. But before I do that, I have to show you a new way of creating strings. So far, we've always created strings in this way, right? On the left, we say string t. We have a variable t that holds a string. We have an equals, and we assign this value to it. And this value is called a string literal. It's called a string literal because it's just literally a string, right? So we just literally have the quotation marks. We have the string inside of it. This is like an int literal is just if you type a number on your keyboard, right? Like, so this is an int literal. However, strings, there's another way of creating strings. So let's say string x equals, and then the syntax that we're going to see for strings is the same syntax as we'll see for things later on. So it's a little bit confusing the first time you see it, but don't worry, we're going to see it a lot. So you're going to get used to it. The first thing is new because we're creating something new, right? The next thing is what new thing are we making? Well, we're making a new string. So we say new string. But then you need parentheses. You need some sort of input. And before I say what goes inside the parentheses, I'm just going to put the semicolon before I forget, because every single line of code needs a semicolon, or every statement. Inside this is actually what is the string that you want to make. So here it's back to what we did before. So if I wanted the string Jack, I'd just put Jack here. However, this is another way of making strings. And we can actually, let's say, string our system out.println x. And I can show you it does what you think it does. It will print out Jack. Right. I can change this to world, and it will print out world. Right. So this is a different way of creating strings, and it's not using a string literal. So this is using a string literal. This is using the string constructor. Why would you want to make strings like that? Well, actually, I will shortly tell you what's the difference between these two ways. And so for the most part, you're just going to make strings like this. Like 90% of the time, even 99% of the time, this is what you do. Don't need to worry about it. It's faster, it's convenient. Basically does the same thing. Basically. But I'm going to show you why I explained this and why you should never use equals equals. Well, if I make the new string hello, just like before, I'm going to print out x. And just for not tricking you or anything, I'm going to print out s. And I'm going to compare x and s. Right? I'm going to say, are x and s equal to each other? And if I run this, you can see x is the string hello, s is the string hello, but for some reason, when I say x equals x, it's false. And so Alan kind of predicted this, it's going to be false. Yeah, so this is false. This is why you should never use equals equals to compare strings, because we'll see that this equals equals is not comparing the contents of the string. So the correct way to say this is the contents of the strings are equal. X and S hold the same value. They both hold the value hello. However, equals equals does not compare the values. We'll see it compares the memory addresses. And so the memory addresses of these things are different. Where they're stored on your computer is different. Yeah, so David, that's why. But I have a few slides to make it a little bit more clear. Before though, I should explain the correct way of comparing strings. Like I said, you shouldn't use equals equals. What should you use instead? There's two main ways of comparing strings. Well, technically there's four on the slide, but let's see, you can kind of see they're very similar to each other. So you have compare to and you have equals. With each of those, you have a ignores case version. So as you can assume, ignores case just ignores the case. So it doesn't matter if it's uppercase or lowercase, it will do the same thing. The difference is what these things return, right? So I'm gonna give you a demonstration, and I want you to tell me something. So let me just let me change S to world again, and let me do system.out.print line t.compare to S. And so this is the correct way of the syntax. So you have one string, t, and then just like every single method that we've seen so far, you do dot the method name. So just like dot length, dot index of, dot char at. Here we're doing dot compare to. And then we need our parentheses. And in this case, this method does need an input because we have one string, we have t, but you need to know what you're comparing it to, right? We're comparing it to S. And so David says we'll return false. Will it return false? So this will not return false. And so let me show you what it returns. It returns, confusingly, -15. Okay, that's a little bit weird. Maybe a little bit more clear is, let's say, string A equals A, string B equals B. Right. So let's compare A and B together. This is going to give you -1. Okay. Well, let's compare A to, instead of B, let's compare it to C. -2. If I compare it to D, it's going to be -3, so on and so on. So compare to returns a number. And the number kind of tells you how far apart they are, right? If it's negative in this case, this means A comes before C, which is what we expect, right? If these are just variables, right? Let's go back to T and S, T dot compared to S. It's basically, if this is negative, T comes before S in the dictionary, right? A before Z, stuff like that. If the number is positive, if it's greater than 0, that means T comes after S, right? So this is something I'm gonna kind of quiz you on in review next week. This plus minus before after. It's definitely a little bit confusing with compare to. But with some practice, it gets a little bit more familiar. And this compare to, we'll see that it actually works with a lot of things, not just with strings. But anyways, that's compare to. Really quickly, does anyone want to guess? What if I do T compared to T, right? Okay, Sarah, I'll explain that again. So Devin says 0, Ellen says 0. Yeah, that's a good guess. It's going to be 0 because they're exactly the same, right? So there is no difference. Right? So the minus things again. Yeah, so question about the minus things again. So let's do it like this. Let's get rid of the variables. Like this, right? No variables. So it's very clear what we're comparing, right? We know in the alphabet that A comes before B. So if the thing on the left occurs before the thing that you're comparing it to, it's going to be negative. -1. If it happens after, right? So C dot compared to B. C happens after B, right? A, B, C. This is going to be +1. +1. the way I like to think about it is everything is centered around what happens first, right? Everything is based on this string, right? So this is your like base string, and you're comparing it to something else, right? So this is some random other string. You don't care about that one as much. You care about this one, right? So thinking about it that way, the positive negative thing, to me at least, makes a little bit more sense, right? Like negative is before, positive is after. Like on the number line, at least, that kind of makes sense, right? Negative is on the left, positive is on the right. That's the way I think about it, right? Hope that was a little bit more clear. The main thing to remember is just the positive negative thing. The actual number itself doesn't matter as much. So when you're using compare to, usually you're just interested in, is it positive? Is it negative? Is it zero, right? That's usually what you're interested in. And based on that, you know how they're related to each other. So that was compare to. Compare to ignore case just ignores the case of things. So this is a little bit where it's weird. If you do like capital A compared to lowercase a, these are not the same. When we talk about characters, every single character has like an ASCII value. It happens that the capital letters have a smaller ASCII value. And so capital A actually happens before lowercase a. And so that's why it's a negative 32. However, if you do compare to ignores case, oh, I think it's not ignores, it's ignore. Then this is gonna return 0, right? It's what you expect. Basically, I think how it works behind the back is it just takes both your strings and maybe makes them both lowercase or makes them both uppercase and then compares them, right? Equals, on the other hand, does not give you a number, right? Compare to gives you a number, an int, plus, minus, 0, whatever. Equals gives you a Boolean value, true or false. Are they equal? Are they not equal? Right? So let's do this. .a equals lowercase a. This will give you not a number, but now it's giving you a Boolean, true, false. Right? So actually compare to kind of gives you a little bit more information. Not only does it tell you if they're equal or not, it actually tells you if it's before, if it's after, how much before, how much after. But it's a little bit more like, I guess, more complicated to use, right? You have to do a little bit more thinking. If all you care about is, are they equal? Then this one might be a little bit more simpler. If all you care about is a Boolean result, then this is the one that you want to use. But they're both two good ways, the correct ways of checking if two strings are equal, right? Always use dot equals, never use the equal signs. This is the correct way. So the difference is, why is this the correct way and why is double equals wrong? So both of them are generally used to compare objects. However, the difference is what they're comparing. And actually, I think I jumped over your question, David. Is it possible to compare numbers? The short answer is yes. But the longer answer is you can't use it to compare ints directly. It can be only used to compare what's called reference types, or basically more complex data types. So we said that ints, doubles, floats, booleans, chars, those are primitive types. They're basically more basic. They don't have as much functionality as more complex types do. So strings are more complex than ints. So strings have these methods. Technically, there's like a complex type equivalent to int. So int is the primitive type. There's capital I integer. So I can say integer I equals 7. So integer I equals 7. So this is like the non-primitive version. So int is the primitive version. capital I integer is the non-primitive integer. And we're actually going to see in use of this later on. But you could compare integers with each other using compare to, I believe, but you can't use compare to compare ints with each other. It has to be non-primitive type. Okay. So back to equals equals versus dot equals. Equals equals compares memory addresses of the two objects. So are they located in the same space in memory? Dot equals usually does content comparison. So it doesn't matter if they're located in different spaces. It's just, is the contents of these objects the same? Right? So sometimes these are going to be true in both cases, right? So definitely, if they're the same memory address, they're definitely going to be the same content because it's the same object, right? It's the same location. There's no way. However, it can be possible that two objects don't have the same memory address, but do have the same contents. That's what we saw right here. So here, T and X have the same contents. They both have the content hello, but they'd have different memory addresses. Right? And so this is the demo that I already did. This is using the non-literal construction of a string. We're using the new operator, the new keyword. And so here's like a diagram of how things work. So when you use string literals to create strings, when you make strings in this way, Java kind of does a shortcut, right? So whenever you make a string, it creates something in the JVM, the Java virtual machine. Kind of talked about the JVM in the very first day when we were installing Java, but it's basically what's running Java. It's like the virtual computer that's running your program. So whenever you make a string literal, it creates that in your virtual machine, right? It's there somewhere. The JRE, it's Java runtime environment. The JRE is this is kind of wrong. Like the JRE is what's running it, and it uses a JVM. So yeah. So basically, when you're making a string literal, well, whenever you're making any string, it makes it into the JVM memory, right? So it makes this Java string. It's in the memory somewhere. When you create a new string using a string literal, Java actually says, okay, have I already created this before in the past? If I have, then I'm just going to point it to the same place. I'm point it to the same memory location. Because I've already made it, why not just reuse it, right? However, when you're using the new keyword, when you're using new, you say, I don't care if you already have it. I need you to make a new one, right? A different one, a new string. Right? You can't reuse the old one that you already have in your memory. You need to make a new one. And so because you say new, it makes a new string, doesn't have a choice. And that string is just naturally going to have a different memory address, right? Like it can't have the same memory address. Otherwise, it would be the same string. And so that's what's going on here. So S3 was a string literal. S4 is another string literal that happened to be the same thing. So it just ends up sharing the same string. However, S1 and S2 were created using the new keyword, right? So when you use a new keyword, it's always making new strings. And so that very not briefly is why you should always use dot equals instead of equals equals. Yeah, no problem. Yeah, if you didn't explain the JVM stuff, the memory location, that's not the important part. The important part is just using dot equals at all times. Before we move on to some more advanced things with strings, I want to talk about like one or two more really useful string methods. So we already saw char at, we already saw length, we already saw index of. Those are very useful. But some probably, I would say one of the most useful methods is the substring method. And so substring, well, it has string in its name, so it's making a string. Sub just means like part of it. So a substring is basically taking part of your original string and like cutting it out and making a new string that's just that bit. And so there's a couple ways of using substring, two to be precise. We're going to look at this version first. So substring, and in the parentheses, you need to give it a beginning index, and you need an end index. Right? So for example, if you have a string, hello all, we are now in the hall, you can say x dot substring 6, 10. So 6 is where we begin, 10 is where we end. We store the result into this new variable. If you look at this line above, though, you don't have to give a start and an end. Right? If you only give it one number, it starts there and goes up to the end. Right? So if we go here, let's try to take the middle 3 letters of world, or at least maybe let's do it the other way. Let's just play around with substring. Right? So let's say string x equals s dot substring, and then I'm gonna begin at 1. I'm gonna end at 4, just some random numbers, and then I'm gonna system out dot print line x. Right. So run this. It should be RL. Oh, I meant to say 1, but doesn't matter, 2 is fine. So it did RL. So can anyone tell me, looking at this, I did substring 2, 4, and the result was RL. Are these starting and ending indices? Are they inclusive or are they exclusive? So does it include the character index 2? Does it include the character index 4? Or does it not include the character index 2? Does it not include the character index 4? And so you should be able to figure it out based on the numbers and the result. So David says the first is inclusive, but the second isn't. And that's exactly right. So it's a little bit confusing why it's different, but that happens to be really useful the more you play around with it. But starting out when you're learning, it is just a little bit more, it is just a little bit confusing. So how you could have figured that out? Well, we know we're doing the substring on S, and we said 2, 4. So let's just check. What is the character at index 2? Well, 0, 1, 2, it's R. And R does show up in our substring, right? And then if we go, what is the character at index 4? Well, R is at 2, L is at 3, D is at 4. Does D show up in our substring? No, it does not. So it doesn't include the end, right? Really quickly, why is this useful? Well, let's just say I want to start the substring at 1, and I want to get exactly 3 characters. Right? I can just say 1 plus 3 here, right? So my start is at 1, my end is 3 later, and this will give you exactly 3 characters, ORL, right? If I did plus 4, this will give me exactly 4 characters, right? If it did include the last letter, then it would be a little bit off and it wouldn't work this way. And that's, I guess, one reason why it's useful to do it that way. Inclusive at the beginning, exclusive at the end. Just really quickly, I will show you the one argument. So substring 1. You start at 1 and you go up to the end. Right? So if you don't specify an ending, it just assumes the end of your string is the end. The second thing, I feel like I already talked about it, although maybe it was in my Python class. So I'll go over it. There's a replace method. So here you have an original string x, and you say x.replace, and then you have two inputs to your method. So the first one is LL, the second one is AA. Just based on the input, you can probably guess LL is what you're finding, AA is what you're replacing it with. So this finds all of your LLs in your original string and replaces them with AAs. Right? It's like a find and replace, if you've ever used that in like Word or Notepad or whatever. It says check that value of x again. I'll just make a note. Everything that we've talked about, substring, replace, charat, whatever, all of these do not modify your original string. So when we say x.replace, it does not actually change x. All it does is takes x, makes the modifications, and then returns a new version, right? That's why we have to store it into a string. If we don't store it into a string, it gets lost forever. Right? We do the replacement, we return it, and then we don't put it anywhere, so then it just goes away. Strings are what's called immutable. So mute means change, im at the front means not, so not changeable. So strings, once you make them, they're fixed. They don't change the value. That's why, going back, that's why you can say, oh, if you make the string hello and then you make the string hello again, you can just point to the same place. That's because you know once you make it, it's never going to change. So that's why it's safe to point two variables to the same memory address. If it wasn't this case, then if you had two string variables that point to the same memory location, if you change one of them, it would also change the other because they're pointing to the same place. However, it's safe to do that because strings can't be changed. All you can do is make a new string and reassign the pointers. Right. This quiz, in the interest of time, I'm not gonna do it today. But quickly, I do want to make a note. This is just using replace. And the replace, you can actually say replace something with nothing. And the nothing is just the two quotes right next to each other, nothing in between. Sarah says, wait, when I input this, it tells me to put a 1 after the x. Sarah, are you talking about the replace? 1 after the x. Oh. I think I was not sharing for a little bit. Which slide were you talking about? Was it the replace or was it substring? Oh, okay. This slide, replace. I guess really quickly, do you want to take the screen share yourself so I can take a look? It's probably just a typo or something similar. No, okay, I can see it. So the problem is, if you notice in line 10, you already create a string x. So in line 16, you can't recreate the variable x. So you can make a different variable like ABC or something. Yeah. Or if you put a 1, x1 is a different variable. So that's how it works. How is it dark mode? I actually don't know off the top of my head. Maybe Sarah can tell you, but otherwise you can probably Google. There's definitely, you can change your appearances. Yeah, I would Google it. It's probably in like your settings somewhere. Yeah, I don't want to get into it that much. All right, here we go. So let's just show it right here. So hello world. So you can do t.replace. And then the thing that I'm replacing is going to be the space. So it's literally just quote, space, quote. And what I want to replace it with is nothing, right? I want to delete the spaces. So I just do two quotes without anything in the middle, right? That's the empty string. There's nothing in there. And so if I run this, or yeah, you see it deletes the space. And so that's how you can use replace to like delete things. Right? That's the only note that you can do this empty string. All right, I think there's this part, which is about adding strings together. And you may or may not have realized you can do this, but you can use the plus sign to add strings together. And when we say add strings together, we just mean we concatenate them. We put them, kind of glue them together. Take one string, take another string, you mash them together. Concat is just the name, the term, concatenation. Yeah, concat is just short for concatenation. So technically, you can use the concat method. I would pretty much never recommend using this. Concrete cat would be pretty cool. Unfortunately, it's not as exciting. So you can use these plus signs. And like, I would always use this. Never use the .concat method, always use the plus sign. No one uses concat. But plus, all it does is just takes two strings and adds them together. That's the most basic use of it. But there's some more like nuances. There's some edge cases. There's some things to point out. The first is like, what happens if you try to add a string with something that's not a string, right? What if you try to add a string with a number, for example? So here I have a couple lines of code. The first three is just creating some variables. I have the string hello. I have the string j, which is 200, but not as a number, as a string, has quotes. And then I have the integer I, 100. So this is a real number. Does anyone want to guess which of these lines below is going to work and which of these is going to give an error? So I will tell you, one of them works, one of them doesn't work. So which one do you think works? I want to take, I guess to make a split. This is number 1, this is number 2. So you can put 1 or 2 in the chat. Which one does not work? Which one will give you an error? So Devin says 2. Anyone else want to make a guess? Or 1 will work, 2 will not work. So 2 people agree that 2 is not going to work. Andy says 2 is not going to work. Yep, so I think we have a little bit of agreement. Yep, Alan says 2. 2 is the correct answer. So 2 does not work. The reason for this, the way I think of it, is kind of what I mentioned in a previous class, how you can put an int to a long, but you can't put a long to an int. Strings are kind of a broader data type than an int, right? Strings can hold things that are not ints, but it can also kind of hold ints, right? So this j kind of holds an int, right? It's not exactly an int, but it's you can see how it's similar to an int, right? So an ints plus more. And so that's why you can add a string and an int together and then store it back into a string. That would work. But you can't add an int and a string and then store it back into an int, if that makes any sense. Basically, what's happening here is when you do t plus I, it converts the int to a string. There's a very clear way of how to convert an int to a string. You just put quotes, right? Simple as that. So you can very easily convert ints to a string. And so what it does when you do t plus I, it converts I to a string, and it just adds t and I together, concatenates them, and then stores them into a new string. On the other hand, there is no clear way of how to make a string back to an int. In this case, you could make a guess. Oh, j is the string 200, so you could convert it that way. But what if j was like ASDF, right? There's no clear way of how to convert a string to an int at all times. And so you can't do this. You can't do I plus j and then store it into an int. You can only store it into another string. We actually saw this in my homework example, which I'll post again. So here's an example where I'm adding a string difference plus a number diff, right? Diff is an int. So what happens here is it takes diff and turns it into a string. And then it adds the two strings together. It does not convert the string to an integer. If you did want to do that, there is actually a way. You can convert some strings to an integer, and that's by using this integer.parseInt function. So it's a little bit of a mouthful, and it's a little bit different than what we've seen before. For the most part, you can just copy paste this line whenever you need it. But integer.parseInt is a method. You can think of the whole thing as the method that takes in a string and parses it into an int, right? So in this case, it's using the same variables as before. J was the string 200. It parses the string into an int. It makes its best guess at what int it should be. And then it turns it into an integer. And then at this point, what you have here is now an int. Now you have the int 200, not the string. You have the int 200. And at this point, you can add two ints together and then store it into an int. No problem. Really quickly in my Eclipse, I can show this off. So let's say, I'll call it J as well. So 101, for example. And then int y equals 5. I can do system.out.print line. I can say j plus y. And so if I run this, what it's going to print out is 1015, right? This is like what people like to say, oh, 1 plus 1 is 11, right? This is what it's doing here. It's just putting it next to each other. However, if you do integer dot parse int on j, so we're parsing j into an int and then adding y. Now this is going to give you 106, right? This is what the real addition is, right? So this is on the slides for reference. Don't have too much time left. So I do have a couple quiz questions. So as like a reminder, if you're interested later on in taking, for example, the AP computer science test, all of the stuff that we've been talking about is definitely going to be on there. And so here are actually a couple of quiz questions off of the exam. Specifically, they test these different methods that we covered: length to find how long a string is, substring to get a portion of the string out of it, index of compared to, all these things that we just talked about this week and last week. These are things on the AP Computer Science test. And actually, if you are really comfortable with the material for these 2 weeks, you could probably ace this section of the test already. Oh, and equals, of course. So for example, with the time left, let's just go over a couple of these multiple choice quizzes. What is the value of pause after the following code executes? We have string 1, S1 is ABCCBA, and we're finding S1.index of B. So what is pause going to be? You can put in the chat or you can speak up. Alan says 1, so that's choice B. Andrew also says B. Does anyone want to say 0, 1, 2, 3, 4? Does anyone want to say C? Right? Because that that is the other, like you could make an argument for that. Right? If you had to guess, it's probably 1 or 4, either B or C. So I think we have 3 answers for B. David says 1, which is B. Yeah, so B is the correct answer. The couple ways to remember it. I mean, the easiest is just to memorize it. Index of starts at the beginning. The other way you could kind of remember it is there is a different function, last index of. So last index of is pretty clear what it's doing. It's finding the last index. And so if you need a specific method to do that, you can assume that the normal index of is doing the first index, right? So index of finds the first index of B, and in this case, it's 1. Here is, again, just testing the different methods if you know what they do. I have, again, string S1, and this is the string MISS space YOU exclamation mark. And I'm doing int len equals S1.length. What is len gonna be? 7, 8, or 9? So Alan says B, Sarah says B. Andrew says C. Andy says B. So they have a little bit of a disagreement. I would say maybe take a look again. It's a little bit tricky, this one. Even though it's just finding the length, it's a little bit tricky. If spaces do count, so David says C. Devin says B. Alan says C. So now we're getting some mixes. So I guess let's say someone who said B, someone who said 8. Can you explain why it's 8? Maybe for this, I'm gonna call on maybe Andy, if you could unmute and explain why did you choose 8? Or Devin says it's 8 because I can count. Well, unfortunately, you might want to take back that statement because the correct answer is actually C. So let me just run it and show you I'm not lying. I don't know why it's always putting a T there. It's 9. So the reason why it's 9, tricky thing, a couple things that you might have been tricked up on. First, there's a space that counts. Second, the exclamation mark also counts, right? So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. Right, so there's actually 9 characters in this string. So those are 2 things you could have mixed up, the space or the exclamation mark. Andy, I'm glad you brought that up because that's another way, that's another thing I wanted to point out. It's a little bit odd, right? We always talk about indexes, we always talk about starting at 0, but length is different. Length is just the length, right? So for length, it's just how many characters are in the string. Right? So a string with 1 character has length 1. This is where the disconnect is. The last index of a string is the length minus 1. So the length of this string is 9, but the index of the exclamation mark is 8. So little difference there. Why this is the case? Well, actually, it's a little bit useful, right? Because we talked about how substring, like s1.substring, the start we can say is 5, and the end, if we want the end of the string, we could leave nothing. But if you wanted the end of the string, you could say s1.length. And so we go that, this will just give you U, right? The reason why this works is the length is actually kind of past the exclamation mark. And we said that substring goes up to, but not including the last number. But since this last number is kind of like beyond the exclamation mark, when we do this, it actually gets every single character up to the end. It's kind of like how all these things fit together. It seems a little bit weird when you're just learning it by themselves, but when you start like using them together, you find it's actually pretty useful how they're designed. With that, I have a couple more quiz questions. I might use these as review next week, or if you want to take a look after class, these will be posted. But getting to the homework, it's kind of similar to what we did last week with just manipulating strings. But I have this input string, please compare Tom and Mary in the classroom. And I want you to remove all the spaces in the string, and that's going to be using replace. Then I want you to use substring to basically cut out Tom and Mary. So I want you to use substring to cut out Tom, and I want you to use substring to cut out Mary from the string. And so store them into other variables. Then use the length function to find the length of the two strings that you cut out and print out the larger one. I mean, that is a little bit dumb because, yeah, we know Tom is 3 letters, Mary is 4 letters. Of course, Mary is going to be longer. But I want you to practice using the Java methods to complete the homework. So don't just like say print 4, for example. Actually print out the length of the variable. Yeah, that's all I have for today. So if you have any questions, I'll be sticking around, but I won't hold you any longer. We'll be continuing on next week, next Thursday. Yeah. So I guess at this point, have a good week and feel free to go. Yeah. Bye, Sarah. Bye, Andrew.
Thank you. Have a great day.
Thank you, David. Miss He, are you there?